Okay, in lesson 6.5, now we'll actually get into using the quadratic formula. And I'm going to add the word two real rational roots. Rational roots, rational means fraction, and this occurs when there is a perfect square under the root. So when you do your b squared minus 4ac and you get a perfect square under there, you are going to get rational roots, meaning fractions, okay, not answers that don't have square roots in them, because we're going to be able to take the square root of that perfect square. Now, this is the quadratic formula right here. And you've used it before. It's a little bit of review. Remember, that works anytime. Factoring only works some of the time, so even problems that are factorable, you could use the quadratic formula to come up with the solutions to quadratics. So we'll say it works all the time. You have to have your quadratic in standard form, which means ax squared plus bx plus c is equal to 0. So you have, because you have to set it equal to 0, make sure it's in that form, and then choose your a, b, and c and plug them into the formula. So, two real rational roots. Let's go through and look at this. Obviously, this is not set equal to 0, this one, so I would have to subtract 33 in my first step. So I have x squared minus 8x minus 33 is equal to 0. That is what we call standard form of a quadratic. Whether you're solving by factoring, solving by the quadratic formula, that's the form you need it in. So now, I would suggest, let's write down your a, b, and c. A is what's in front of x squared, so a would be 1. B is what's in front of x, which is negative 8. And c is the constant term, which is negative 33. And now we're going to plug into the quadratic formula. So x equals the opposite of b. So this says the opposite of b right here. So if b is negative 8, I want to take positive 8. Take the opposite, plus or minus the square root of b squared. So I want to do negative 8 squared minus 4 times a, which is 1, times c, which is negative 33. And all that's all over 2 times a, which is 1. So 8 plus or minus square root. Let's figure out what the number is under the square root. Very important here that you put negatives inside parentheses. And I would suggest just typing in everything underneath here into your calculator. Don't hit the square root button. I want to figure out what that is underneath. So I'm going to pull up my graphing calculator. And I'll clear that out. So here's what we have. I have, in parentheses, negative 8 squared minus 4 times, and I'm going to go ahead and put the 1 inside there, times 1 times negative 33. And notice how I'm typing that in. So that's 196. So if we go back to the screen, I get 196 underneath the square root. On the bottom, 2 times 1 is 2. 196 is a perfect square. Okay, so this is a perfect square. The square root of 196, if you actually took it on your calculator, is 14. So this becomes 8 plus or minus 14 all over 2. Now that breaks down into, this is how you get two answers for this one, which happens a lot in quadratics. 8 plus 14 divided by 2 will be one answer, and 8 minus 14 divided by 2 will be another answer. 8 plus 14 is 22. 22 divided by 2 is 11. There's one solution to that quadratic equation. 8 minus 14 is negative 6. Negative 6 divided by 2 is negative 3. Those are what we call two real rational roots. Rational means fractions, no square roots on your answer, and you need to know what type of roots. Now we're going to get one real, so I'm going to put the word real in there, rational root. That occurs when you get 0 under the square root in the quadratic formula. Thus, you have plus or minus the square root of 0, which is 0, and you only end up with the root being the opposite of b over 2a. The plus minus is what creates two answers if there are going to be two answers, and if you get a 0 after that, that eliminates the two answers. As you can see, this is already in ax squared plus bx plus c equals 0 form. We don't have to do any maneuvering. So let's go ahead and write down our a, b, and c. A is 1. There's a 1 in front of x squared. B is negative 34. C is 289. Quadratic formula. Take the opposite of b. B is negative here again, so it's 34. Because b is negative 34, but I want the opposite of it. Plus or minus now under the square root. Very important that you put negative 34 in parentheses, square on the outside, minus 4 times a, which is 1, times c, which is 289. All over 2 times 1. In your next step, you always want to use that calculator. Type in what's underneath the square root. So in this case, I have in parentheses negative 30, So I have negative 34. Oops, I got to put it in parentheses, so let me back up a little bit. So parentheses, negative 34 and squared minus 4 times 1 and then left parentheses times 289. So there's what's underneath my square root, and I get 0. So if we come back over here, that evaluated is 0. So I have 34 plus or minus the square root of 0 all over 2 times 1, which is 2. This drops out. Square root of 0 is 0, which eliminates two answers because there's nothing after the plus minus. So the only thing left is 34 divided by 2, which is 17. One real rational root. And by the way, when they say the solutions to a quadratic, solutions, roots, zeros, those are all interchangeable words used. Also, if you look at it graphically, they would be the x-intercepts. All of those are interchangeable words for solutions to quadratics. So there's one real rational root. Irrational root, this would be 2 real irrational roots. That occurs when there's not a perfect square under the root. You get a number under there. A positive. Okay? And you have to leave in simplified radical form. Make sure you leave in simplified radical form. No approximate decimals. So simplified radical or root form. Which means if it's a square root that can be simplified, if there's perfect square factors, you have to do that. If you notice, this is already in ax squared plus bx plus c equals 0 form. I don't have to do any maneuvering. So A would be 1 because that's what's in front of x squared, B is negative 6, and C is 2. Let's plug them into the quadratic formula. The opposite of B, so B is negative 6, that means I want positive 6. Plus or minus, negative 6 inside parentheses, squared minus 4 times A times C, which is 2, all over 2 times 1. A lot of numbers to plug in. Leave the 6 plus or minus, figure out what number's under the root with your calculator. So we have negative 6 squared. So if I go back here again, I have negative 6 in parentheses squared minus 4 times 1 times 2. And as you can see, that gives me 28. So underneath here, I get 28 all over 2 because 2 times 1 is 2. Notice there's not a perfect square under the root, which makes it irrational. Any squares roots that don't come out to be whole numbers makes it irrational, and it's going to be 2 answers because of the plus minus symbol. So what you need to do is you need to think about the square root of 28. Can I simplify it? Is there perfect square factors? If you think about your perfect squares that we talked about, all that stuff and reviewed in chapter 5, 4 goes into it 7 times. The square root of 4 is 2. So it's 2 square root 7. So this really becomes 6 plus or minus 2 square root 7 all over 2. Now, you have to check if you can simplify. If there is, with the number in front of the root, if there is one, and the number out in front of the plus minus symbol, and the number on the bottom, if there is a common factor of all of them, you need to reduce. Can you see that 2 goes into all 3 of those that I circled? 2 goes in there once, in there 3 times, and in there once. So this really means x is equal to 3 plus or minus 1 square root 7 or square root 7 over 1. And I don't really need to write it over 1 anymore. So my answers would be 3 plus square root 7 and 3 minus square root 7. And you need to leave them exact, no decimals. Okay? You can leave them as plus minus, showing your 2 real irrational roots that way. But that is 2 real irrational. Anytime you have a root left on the answer, it's 2 because of the plus minus symbol still being in there. Those would be the roots, the zeros, the x-intercepts, all those interchangeable words I talked about earlier. Complex roots are going to have the imaginary unit I in them because that occurs with a negative under the square root. Okay, we just reviewed that at the end of chapter 5. Now if you notice, if you look at this, this is not set equal to 0. I need to subtract 6x to get rid of it on this side, so I'm going to do it here. And you want to write this in what I call descending order. So x squared term first, then the minus 6x, then the plus 13 is equal to 0. Now we are in ax squared plus bx plus c form. Let's write down our a, our b, and our c. A is 1, b is negative 6, and c is 13. Let's go ahead and plug them in. I want the opposite of b, so that's going to be 6, because I take the opposite of negative 6, plus or minus b squared, so negative 6 inside parentheses, minus 4 times 1 times 13, all over 2 times 1. Let's go ahead and simplify. 6 plus or minus, and underneath there, let's go ahead and use our calculator again. So inside parentheses, we have negative 6 squared minus 4 times 1 times 13. If you notice, Oops, let's go ahead and do that again. I think I got the wrong answer. Let's clear that out. Let's try this again. I have negative 6 squared minus 4 times 1 and then times 13. Okay, I entered something incorrectly before. So we get negative 16 under the root. And then on the bottom I have 2 times 1, which is 2. Alright, now we look at this. Can I simplify this? Now, it's a square root of a negative, which is going to put the I on there. So if you think about the square root of negative 16, like we did at the end of chapter 5, the square root of negative 1, which is going to produce the I, and the square root of 16. 16 is a perfect square, so the square root of 16 is 4. So we're going to represent that as 4I. So it's 6 plus or minus 4I all over 2. And if you can reduce with these 3 numbers, you need to do it. 2 is a common factor, goes in there once, in there twice, and in there 3 times. So this is 3 plus or minus 2I. So it's 3 plus 2I, 3 minus 2I. Those are two complex, so they're not real anymore because they have I on them, 2 complex roots. So when they say state the kind and number of solutions, 2 complex roots. Anything with I in it. Now, if you had the square root of negative and it wasn't a perfect square, you put it in simplified root form. But if it has I on it, it is complex and occurs when there's a negative underneath the square root.